Hello, I am Saran.
Let us write a program in Prolog to implement Towers of Hanoi. Towers of Hanoi is a very classical problem. So here we will be having to move disks from one peg to another peg. So let us define this problem at first. So this is the problem of Towers of Hanoi. So this is a famous puzzle is to move n number of disks from the source peg to the target peg using the center or the intermediate peg as an auxiliary holding peg. At no time, there are two constants are there. At no time can a larger disk be placed upon a smaller disk. So that is the first condition. The larger disk cannot be placed on a smaller one. And the second condition is that at a time only one disk can be moved from one peg to another peg. So this is the problem for us, and here this value of n will be supplied by the user, so that number of disks are to be moved from the source to the target peg, keeping the intermediate or the center peg as auxiliary peg. So this is the source peg, this is the target peg, and this is our intermediate peg. Okay. Now the problem is that here we have considered that the value of n, that is the number of disks, is equal to 3. So how to write the respective predicate for it? So here we are supposed to write one procedure, that is move n source target intermediate. So the second argument, the first argument will be the number of disks in the system or the number of disks to be moved. So and then source is from the source peg to the target peg, keeping the intermediate as the auxiliary peg. Now let us go for the execution. That means we are supposed to write the respective program code and we should have to execute it. So for this one, we require one procedure to be written, and the name of the procedure, let it be move. So move n number of disks from the source to the target, keeping the other peg, that is the intermediate, as the auxiliary one. So if we execute my program, if we execute our program with n is equal to 3, so move 3 source target intermediate, then these are the moves will be suggested by our program. So topmost disk, that is the smallest one, will be moved from the source to the target. Then topmost disk from the source to the intermediate, that is the intermediate size disk, will be moved to the intermediate peg. Topmost disk from the target to the intermediate, that is the smallest one, will be moved from the target to the intermediate. So to source peg is still with the largest size disk. So disk will be moved from the source to the target. So largest size disk has gone to the target, and topmost disk from the intermediate to the source. So it will be moved there, and topmost disk from the intermediate to the target. So intermediate size disk will be going to the target. So target is now having two disks, the largest one at the bottom and intermediate one at its top, and the smallest one is at the source. So from the source to the target, the last disk will have to be moved. So in this way, my program will give you the output. Okay, good. So this is the predicate to be written. The code has to be developed. This is the output. The sample output is in front of us. So right now pause the video at this stage and try to write the code yourself. Otherwise the demonstration is always for us. So here we are going to implement Towers of Hanoi problem. So in case of Towers of Hanoi, we are having three pegs. One is the source, next one is the target, and the last one is the intermediate one. And we are supposed to move n number of disks from source to the target accordingly. And obviously disk size will be a matter here. That means the larger size disk cannot be put on the smaller size disk, and at a time only one disk can be moved. So these are the constraints for this Towers of Hanoi problem. So now what is happening? We are going to write the move clause. In the move clause, we are writing that a single disk we are moving from the source peg, that is X, and target peg is Y. So other peg will be kept as the intermediate. So whenever we are having a single disk, so that is very easy to get moved. So here the code is move top disk from right X, that is from the source, to right Y, that is to the target. NL means the new line. So next line will get printed from the fresh line. Okay, so that is my move whenever we are having a single disk to move. But whenever we are having n number of disks to move, then what will happen? So here we are having n number of disks. So value of n is greater than 1. M is n minus 1. So out of this n number of disks, let us move m number of disks, and then the last one will be moved accordingly. So m number of disks will be moved from X to Z, keeping Y as intermediate, and then the last disk, which is the largest one out of this n number of disks. So the large disk or the last disk will be moved from this X to Y, keeping the other peg as intermediate, and those disks which moved ultimately to Z, then those m number of disks will be moved from Z to Y, which is the ultimate target, Z to Y, keeping X as intermediate. So in this way, my code has been written. So let us go for the execution for the better understanding and so on. So here we are having my code. So this is my code. The program has got compiled automatically. So I have compiled it and the program is now residing in the memory. So listing. So this is my listing of the code. Whatever you are finding, you are getting the same thing here. Only the variables have got renamed by the software. So move 3 disks from source to target, and this one is the intermediate. Always remember, this sequence is very vital. First one is the number of disks. Here I put 3. The second one is the source peg. Here I put the name of the peg as source. Here is the target peg, so I've written target, and this one is the intermediate, so I've written intermediate accordingly. So this sequence is very important. So let me put one full stop here and let me execute. So it is telling that at first source to target one disk will be put, then source to intermediate one disk will be put, then target to intermediate another disk will be put, then source to target, that is the third disk, that is the largest one, is getting moved, then intermediate to source, that is the smaller disk, rather the smallest one, so that has been put to source. Then intermediate to target, that is the intermediate size disk, will be moved to the target, and then source to target. So in this way, we are getting the sequence and steps what are required to move these 3 disks from the source to target, keeping other peg as intermediate. So let me go for this 5. It will give us the solution accordingly. So these are the required steps required to move 5 disks from source to target, keeping the other peg as intermediate. I think you are getting this logic. Thanks for watching this video.